Hi, my name is Jemin, and I'm an engineer at ComEd. Today's lesson's core content is about what fuels nuclear energy: uranium. Nuclear energy is created by splitting the nucleus of tiny particles called atoms. It's a really big deal in Illinois because Illinois generates half of its electricity from just 6 nuclear power plants. These 6 power plants make Illinois the largest generator of electricity from nuclear energy in the United States. Let's take a closer look at the science behind nuclear energy. Why is this tipped over? When we talk about nuclear energy, it's really all about the energy inside the nucleus of an atom. There is an enormous amount of energy in the bonds holding an atom together. The energy holding this nucleus together can be used to make electricity, but first the energy must be released. In a nuclear power plant, atoms are split apart to form smaller atoms, and when they split, they release a lot of energy in the form of light and heat. We call this process fission. Uranium is what we fission in a power plant. It is a common, non-renewable metal found in rocks all over the world. We use uranium because it is unstable or radioactive, which means its atoms easily split apart. Overall, uranium isn't very radioactive at all. You actually get more radiation from the sun. But it's radioactive enough that we can use its splitting personality to help generate electricity. In a nuclear power plant, the reactor is where the fun happens. The reactor is made of a core of long, narrow rods filled with the uranium. These fuel rods are bombarded with neutrons. The first uranium atom to be hit will split and release a ton of energy and a few more neutrons. Those neutrons cause other uranium atoms to split, and this causes a chain reaction that produces a lot of energy we can trap as heat. We trap this heat with water, which evaporates into steam. The steam spins the turbine that generates electricity. Because the fuel is radioactive and becomes even more radioactive after fissioning the atoms, we have to take care of it properly. After the fuel is used up, we have to keep the used fuel contained on site at a nuclear power plant until the material is less radioactive. The used fuel will continuously lose its radioactivity with time until it becomes stable. As long as the material stays on site, trapped behind materials that block radiation, we get all the electricity and none of the harmful radiation. All radioactive materials have a property called half-life. For example, uranium's half-life is how long it takes for half of all the uranium atoms to decay into another type of atom. Let's look at how this works with licorice. You're going to need licorice, and you're going to need a piece of graphite. Label the y-axis radioactivity, and label the x-axis half-lives. First, what I'm going to do, I'm going to take my licorice, and I'm going to mark how tall it is on my graph. So you can see this mark here, that's how big my licorice is. Next, what I'm going to do is I'm going to break my licorice in half. Okay, I'm going to set one piece aside to eat for later. And I'm going to take my new half piece of licorice, and I'm going to mark it on the graph at the next point, at number 1. So you can see, here's 0, that's the size of the licorice I started with. Here's the size of the licorice after 1 half-life. I'm going to keep doing this for as many half-lives as I want until I fill up the graph, and we'll take a look at the final product. Okay, so I finished graphing my pieces of licorice every time I split it in half. Now I'm going to connect all these points with a line. Alright, and your decay curve is going to look like this. So as you can see, our uranium, which is our licorice, kept seeing its radioactivity decrease with time and become safer. All radioactive matter decays in this process, and all decay or half-life graphs have the same shape. What does yours look like? Don't forget to snap a pic of your half-life curves Submit it with your answers to the questions to the email listed on the screen, stemneverstops@comment.com.